Hello and welcome back to Mr. Powers Teaches Math. This video is just to help us look at how we might use technology to check our work with these guys. So this is the work we did last time. We're rationalizing denominators and these kinds of expressions where there's roots, right? And really we're just trying to get rid of the root. No roots in the bottom. But there's lots of ways to rewrite something with a root or without a root. For instance, I could have done something else right here, and I could have gotten 4x root x, and I mean just to show you, this guy could have been 4x root x over x squared, and that would still be rationalized, but it's not reduced. We also want it to be as simple as possible. These x's here, these x and the x squared, they cancel, so we can get back to this guy right there. Okay, so how can we use technology? And I'm just mentioning that because sometimes the technology will want to do it a certain way. It'll be very unintuitive the way we do it. And sometimes it won't. So anyway, Symbolab is a great way to do it. We already saw what our result was right here, 1 over 3 minus root x. What do we get when we rationalize it? 3 plus root x over 9 minus x. We can type it in here using our calculator and these fun buttons up here. We hit go, and and we get exactly what we'd expect. So sometimes it's great, it looks perfect, and that's the way we'd write it anyway. And it shows really good work. Some steps there, it's really nice. Very useful. And now, what about this other example we did, right? This root 5, or the fifth root of 2 over x cubed. What about that? Remember, that one was a little funny. We had to rewrite it with fifth roots, top and bottom, then rationalize. And our rationalizing, we were thinking, well, I want to get rid of my fifth root, so I want an x to the fifth below it. So we multiply top and bottom by the fifth root of x squared. You'll see here, it's not going to do it that way. Rationalize, the same thing, fifth root of 2 over x cubed, and it gets something, and it looks a little different. But is that the same? Going back here, is that really the same thing we got before? It looks really similar. It looks really similar. We just got to say, well, is the fifth root of 2 times x to the 2/5 the same as the fifth root of 2x squared? We need to figure that out. Okay. We can do that just for fun too. Look at its steps. The steps here, where does he get that x cubed to the 4/5? Now it works, but they're thinking different. There's more than one way to attack these, but eventually we get to the same spot because it does get some x squareds and it simplifies those out. Okay, cancels them out. Here's what we can do. What we can do is take this weird denominator and rewrite that x to the 2/5 as a root. And we got that trick right here. Remember, we had that trick before. We had to use this before when we're dealing with roots, just the way it goes. So that we have this property, x to the m over n is the same as the nth root of x to the m. So we can rewrite it, the fifth root of 2 times, okay, and then this guy right here, the x part, is going to be the fifth root, because the 5's in the denominator, fifth root of x squared. Okay, we've got all that over x. And is that really the same thing? We can multiply these, and we get the fifth root of 2x squared all over x. Yes, we got the same exact thing. Can technology still get us here? Let's see. Because remember, our trick before was to rewrite weird stuff like this. Rewrite that like the roots. So let's see. If we did take that and rewrote it like that as roots, type it in, yes, it would do that numerator part for us if we wanted to type it in separate. It would totally work. So there it is. That's what I wanted to show you guys, is how we can use technology to check our work. It takes a little bit more fiddling sometimes. Sometimes it doesn't. So until next time, enjoy doing math.